nearest neighbors, decision trees and naive Bayes for classification. We are presenting the results of training and evaluating three machine learning models, K nearest neighbors, decision trees and naive Bayes on the mall customers dataset. The dataset contains customer demographic information and spending behavior. The models aims to classify customers into spending categories low, medium and high. Now I am going to explain about our code. Import pandas as PD. It loads the pandas, a powerful library for handling structured data like tables. PD is the shortcut used throughout the code. And next line, import numpy as NP. Imports numpy, the go-to for number crunching and works with array. Import matplotlib pyplot as a PLT. Imports matplotlib's plotting module for creating graphs. PLT is the alias used to draw plots. Import Seaborn as SNC. Import Seaborn as statistical data visualization library built on top of the matplotlib. Form Skylearn model selection import train test split brings in the tool to split your data into a training and testing set. From sklearn.preprocessing import standard scalar and label encoder. Standard scalar which normalizes numerical values to the standard range mean is equal to 0 and standard is equal to 1. Label encoder which converts categorical text values into numeric labels. From sklearn.neighbors import kneighbors classifier. Imports the k nearest neighbors algorithm for classification tasks. From sklearn.tree import decision tree classification. It imports the decision tree classifier, a model that makes decision like the flowchart. From sklearn.naive Bayes import Gaussian NB, which loads the naive Bayes classifier assuming a normal Gaussian distribution of features. From sklearn.metrics import accuracy score, precision score, recall score, F1 score, classification report, which brings in metrics to evaluate model performance, for example, how accurate and precise it is. Second, load dataset. File path is equals to mallcustomers.csv. In there, we ensure this file is in the correct directory. Sets the name of the file to be read. The script expects it in the same folder. Try, which begins a try block to catch errors in case the file isn't found. Df is equal to pd.readcsv file path, which attempts to read the file into a pandas data frame named df. Except file not found error. If the file is missing, the code inside this block runs. Print error, dataset file not found, please check the file path, which shows an error message to help the user locate the problem. Then stops the program from continuing if the file isn't found from exit. Third one, rename columns for consistency. df.columns is equal to customer ID, gender, age, annual come, spending score. These are the list renames the column of the data frame so they are clean, readable and standardized. Ensures further steps don't break due to the inconsistent names. Encode categorical variables. Label encoder is equals to label encoder, which creates an object to transform text labels into numbers. df gender is equal to label encoder dot fit transform df gender, which transforms the gender column, converts categories like male, female into numeric codes like 1, 0. Next will be continued by Likita.
This code is the part of machine learning data processing pipeline, likely preparing data for a classification model that predicts spending categories. Let's go through it line by line. Defining spending categories. DF spending category. PD cut DF spending score. Uses PD cut to bin the continuous spending score into categories. The result is assigned to a new column called spending category. Bin 0, 40, 70, 100. Specifies the bin edges 0 to 40 low, 40 to 70 medium, 70 to 100 high. Labels low, medium, high. Labels assigned to bin above. Include lowest is equals to true. Ensure that the lowest value 0 is included in the first bin. DF subset spending category in place true. Drop any rows where spending category could not be assigned. Example, if spending score was NAN. X is equals to DF, gender, age, annual income, spending score, copy. Creates a copy of selected futures for input X. X, age, annual income, spending score is equals to X, age, annual income, spending score as type float. Ensure that numerical columns are of type float which is required for scaling. Y is equals to DF, spending category, copy. Sets the target variables Y as the spending category columns. Normalize numerical features. Scale is equals to standard scalar. Initialize standard scalars to normalize numerical features. Mean is equals to 0. Standard is equals to 1. Scaled futures, scalar fit transform X age, annual income, spending score. Fits the scalar to the data and transport the values. X, LOC, age, annual income, spending score, scaled features. Replace original numerical columns which their normalized version. Ensure when we N of the training samples, if land DF 10, checks if the data set has fewer than 10 rows. Print not enough data to train models reliably. Please use a large data set. Exit. Stop program executions to prevent training on insufficient data. Next we'll continue it by Nisha.
X train, X test, Y test is equal to train test split X Y test size is equal to 0.3, random state is equal to 42. Purpose this line splits the data set into training and testing subsets. X features data input, Y label or target variable. Test size is equal to 0.3. 30% of the data will be used for testing and 70% for training. Random state is equal to 42. Ensures reproducibility by setting a fixed seed for a randomization. X train is training features, X test is testing features, Y train is training labels, Y test is testing label. K is equal to max 1 minimum 5 len X train determines a valid value of a K for the KNN classifier. Len X train gets the number of samples in the training set. Len X train 1 ensures that K is less finds a valid value of a K for the KNN classifier. Len X train gets the number of samples in the training set. Len X train ensures that the K is less than the number of training samples. Minute 5 Len X train chooses the smaller value between 5 and the total training sample minus 1. Max 1 ensures that K is at the least 1. KNN K neighbors classifier N neighbors is equal to K. Initialize a K nearest neighbor classifier using previously calculated value of a K. Decision tree classifier random state is equal to 42. Initialize a decision tree classifier with a fixed random state for reproducibility. NV is equal to Gaussian NV. Initialize a Gaussian NV bias classifier. KNN fit K train and Y train trains the KNN model on the training data. DT fit X train Y train trains the decision tree model on the train data. Next will be continued by Harshita M.
Make predictions. Y predict KNN equals to KNN dot predict of X test. The K nearest neighbors models makes predictions on the test data. X test. Results are stored in the Y prediction KNN. Y predict decision tree equals to decision tree dot predict X test. The decision tree model predicts using the same test data. Prediction go into Y predict delete. Y predict NB equals to NB dot predict test. The Navy based model makes predictions on X test. Results go into the Y predict. Functions to evaluate models. Defines a function called evaluate model that takes name string, name of the model, example KNN, Y true, actual labels, Y predict, predicted labels. Print name model performance. Prints a heading to show how model is being evaluated. Print classification report of Y true, Y predict and 0 division equals to 1. Displays a detailed classification report. 0 division equals to 1. Avoids division errors when there is 0 is in a denominator. Return. Starts the return statement to send back a directory of key matrices. Model name. Adds the model name to the dictionary. Accuracy. Accuracy score Y true Y predict calculates and includes the accuracy score of the predictions. Precision. Precision score of Y true Y predict average equals to weight and 0 division. Calculates weighted precision. 0 division equals to 1. Handles any divide by 0 issues. Recall. Recall score Y true Y predict average equals to weighted. Calculates weighted recall. F1 score of Y true Y predicts average equals to weighted. Calculates weighted F1 score. Ends the directory and return value of the function. Evaluate all models. Result. Initialize an empty list to store evaluation results for all the models. Result.append evaluates model KNN Y test Y predict KNN. Evaluates the KNN model and append its matrices to results. Result.append evaluates model decision tree Y test prediction. Result.append evaluate model decision tree Y test Y predict. Evaluate the decision tree model and adds the result. Result.append evaluate model Navy base Y test Y predict NB. Evaluates the Navy base models and appends the result. Convert results to data frame. Result df equals to pd.data frame results. Convert
Cursor. Result DF accuracy. This selects the accuracy column from the data frame called result DF. It contains accuracy scores for each module. .index max. This function returns the index row table of the highest value in the accuracy column. It helps us to find which module has the highest accuracy. Result df.location is used to access a specific row and column by label. Here we are using the index from index max to locate the row, and from that row we extract the module value. Best module is equal to. This stores the name of the module with the highest accuracy in the variable best module. Print best performing module. This is the formatted print statement f string. It prints the name of the best module stored in best module. /n just adds a new line for better reliability in the output. plt.figure. Create a new figure for the plot. Figure size is equal to 10,6. Set the size of the plot 10 units wide and 6 units tall. This makes the plot clearer and more readable. Plot a bar chart using C-bar. SNS.barplot. Plot a bar chart using C-bar showing model accuracy. X is equal to model. Model like KNN decision tree, Navy base go on the x-axis. Y is equal to accuracy. Value go to the y-axis. HUV is equal to model. Color each bar based on the model. Each model get a unique shade of blue. Data is equal to result DF. Uses the data frame result DF that contains model names and their accuracies. Palette is equal to blues. Apply a blue color gradient to the bars. Legend is equal to false. It's already clear from x-axis label. plt.title. Model accuracy comparison. Adds a title at the top of the graph. Model accuracy comparison. plt.ylabel accuracy. Label the y-axis as accuracy to show what the vertical values represent. plt.ylim 0, 1 sets the y-axis range from 0 to 1. Plot.show. Display the final plot. It is the output of our code. From the console output, we can see KNN has accuracy of 0.67. Decision tree and Navy bias both have 1 accuracy. However, based on precision, recall and F1 score, the decision tree is selected as the best.
Conclusion. Decision tree and Navy bias performed best, achieving 100% accuracy. KNN had moderate performance, 67% accuracy, likely due to dataset size and distance-based calculation. The dataset size is too small for generalization and further testing on larger samples is recommended. Future improvements included increasing dataset size, turning hyperparameters for decision tree and Navy bias, exploring ensemble models for better performance. Thank you.